Now, if we truly understand the second part of this assignment, the third part is just a neat reapplication of the code we had in the second part. And it is actually displaying the values in array 1 that are not in array 2. Referring back to our concept, we see that what we want is everything in the first set minus whatever it is also exists in the second set. And how do we do that? That's how we do it. We're gonna take we're gonna take each value in our first set and compare it to every value in the second set and ask ourselves if there is any instance of equality. If there is, then we're gonna put a mark on it. In this case, our Boolean statement. We're gonna put the flag as true. And we're gonna make sure that we're not gonna print it. For example, we're not gonna see any 2 in the second in multiples of 3. What we're gonna see, however, is an 18. It's also in the first 10 multiples of 2 and the first 10 multiples of 3. So we're gonna make sure that we don't print 18. Now, code-wise, this is what's going to happen. Again, we're going to have a for loop that runs 10 times. This first loop runs through the indexes of our first array, right? Multiples of 2. We're going to make sure our flag is false to begin with. And we're going to go to our nested loop, which this loop basically runs through all indexes of the second set, first 10 multiples of 3. And then in doing so, it's going to ask the important question. It's going to compare the index I of array 1. It's going to ask if the index I of array 1 is equal to the number in index j of array 2. If so, flag is true. And so the value of index I exists in both arrays. So we're going to make sure not to print it. And getting out of the nested loop, we're going to print the value of index I of array 2 if the flag is false. And that's the instruction. If flag is false, then print the index, the value in the index I of array 1 right here. And it's going to print that. We're going to run this code and see if it works. What we expect to see is the first set of numbers minus the intersection. See 2, 4, 8, 10, 14, 16, 20. Looking at our concept, 2, 4, 8, 10, 16, 14, and 20. Correct.